Hi guys, welcome back to part 2 of these tutorials where we are trying to build this tower, the Cactus Towers by Big. Alright, so in part 1 we went over the slabs, and if you recall, if I go back to my Rhino file, the rotation that we've done for these is actually based on a random number. Okay, so go to part 1 to see how we did this, but we basically generated a series of random angles, right, using the random component, and rotated each slab that way, and that's how we got this look that we have right now. However, when you look at the actual image, you'll see that the only way that the vertical connections here, right, these columns, so to speak, that they are actually made is through the corners. Okay, so each time there's a corner, you'll see that these things go through and they actually touch other corners. So when you analyze this building, you'll see that, well, there's only a certain fixed number of rotations. Okay, it's not as if there is, a whole bunch of random rotations going on. There are only a certain number of degrees, and we can probably count them. There's there's 1 here, 2, 3, 4, maybe 5 different rotations going on. And if this is a square slab, the moment it rotates 90 degrees, it's really the same slab. So between 0 and 90 degrees, there's a couple of angles going on. So let's try, instead of using we will still use the random component, but we're not going to choose any random angles. It's going to be a fixed number of angles that we choose from, and I'm just going to show you guys how to do that. Okay, so before we go into those vertical pieces, we're still on the slabs here. So let's go over to where the random component was, which is here. And again, it's generating a series of angles. And last time we had set the angles to go between negative 90 and 90. But what I am going to do right now is just create a fixed series of angles. So let's say the first angle I want to create in this panel is 0. And then I'm going to do 30 degrees. Maybe I'll just do 60 degrees. And maybe there's also 45. Who knows, right? So 30, 45. If we're really going to do that, then we're going to end up with this. I don't want to add 90, because if I put in 90, then 90 will be the same as 0, because these are all squares. So if I rotate it by 90, it's really the same thing. So 0 degrees, 15, 30, 45, 60, 75. I'm just going to leave it as that. Now, of course, this is not a list of data. This is just a bunch of information, so to speak. But I want to turn this into usable data that I can use in Grasshopper. Right click and make sure that this is checked off. So it doesn't think it's multi-line data, but rather each data is on its own line and is its own item. So the first item, 0, 15, 30, 45, 75. I can call these rotation angles. And just take off there. Okay, so rotation angles. All right, now what I need to do is realize that this random number can't really pick out of these random things. Like, I can't put this in here as my range, right? It's just not going to work. It's going to give me, something completely different. That's really not what we're trying to do. So what I really want to do is I want to use the list item component. Okay, and the way list item works is, just a quick recap. Just going to do a simple example here where list item, essentially you enter an index. So I'm entering as my index 0, so it's going to give me a rotation angle of 0. So I'm going to, if I enter 1, it'll give me the next number down, which is 15, 2, 3, 4, 5, and so on. So it gives me the different angles. However, I don't want to choose this number. I want this to be random. Okay, so from 0 to 5, I want it to be a random number. So instead of this domain going from negative 90 to 90, it's really going from 0 to 5. So now what this is going to do is choose a random number between 0 and 5. Okay, and that I can put into my list item component. However, look at these. The list item component should require an integer like 0, 1, or 2, not 2 point something, or like this number 2.8. It's not going to do anything with that. So what I should do is use the integer component, and what this will do is convert any of these numbers, these floating numbers coming in here, into integers. And that's a quick way of just cleaning that up. Now if I put this in here into this index, I can see that now on one hand I have the index, and on the other hand I have the angles, and notice they're all random, right? I didn't actually choose these. It comes out of the random number generator. So now instead of rotating them by a random angle, they're still going to be rotated by a random angle, but only one of certain angles that I have chosen. I'll make sure this is the right unit. There we go. Okay. Just tie that in here to the angle component. Let's have a look at our building. So now you see it's very close to the building that we just saw, and it's only rotating by a fixed number. I'm going to make this building a little shorter. Just so it matches the scale a little bit more of what we saw earlier. We can even reduce the number of angles if you don't want all of these. So you could take out, say, 15 and 75 if you didn't want to. You could really do whatever you guys want. All right, let's come and do the actual vertical components now that we're trying to do. So in order to do that, I don't think I need these slabs themselves. What I really need is just the boundaries, right? If I go back and look at an image of this, if I have the boundaries, I should be able to somehow connect between the boundaries to create this, this type of structure here. So let's go back. And so the boundaries are where? They are actually coming out of this rotation component. Okay, so if I isolate this, you'll notice that these are just a set of curves, which is perfect, which is exactly what I need right now. So I'm going to make sure that there's a curve component here. And this is called rotated slab boundaries. Okay. And by doing that, I remember what this component is. And what I'm going to do is copy this component over. Now you don't have to do it exactly the way I'm doing it. I'm just used to doing it this method. It's just so that things stay a little organized. But I'm going to call this section vertical connections. Okay. So vertical connections, and I'm starting with the rotated slab boundaries. Just to bring everything else back in. Maybe I will hide all this stuff here. So go ahead and hide those. So all I'm seeing is the rotated boundaries. All right, so let's go back to the image. So what I need to do really is find a way. Now I can find the corners. That's really not the hard part. But notice that as these slab pieces are being cut through, right, they're not always cut at the corner. So this piece of vertical, this vertical fin column piece is going to intersect the slab at multiple locations. And so that's really what we're trying to achieve, is find a way to find out where this line is, right, in three-dimensional space, whether that's a plane or some type of surface, and cut all of the slabs along that line to get a series of points. And then I can probably draw a polyline or something along those points to create this vertical fin. All right, so let's try and do that. If I go back to Rhino, first I need to figure out where am I trying to draw these. If I go in my top view, you'll see that I really want to draw these along these corner points. Now, there's a way to get those corner points. If I go here to the boundaries, I double click, I can get the control points. And you see that the control points component actually gives me all of the corner points. There's another component that I like a little better, just because sometimes, even though you may have a straight line, you may have control points along that straight lines. I'm looking for specifically the corners. So when I'm looking for corners, there's a much better component called Discontinuity. And this component actually gives you a much better result about what the corners, where the corners actually are. It'll never pick up a point along a straight line. If I look at this in 3 dimensions, you'll see that the points are scattered all over the place, right? So in order to make this just easier for me to look at, I am going to put all the points on the ground plane and just look at this in 2D for a second. So one way to do that is to project all the points. Double click and type project. And I'm going to select this component, project an object onto a plane. And if I put in the points, right, as my geometry, The plane is the default world XY plane. So if I go back into my perspective view, while I have that component selected, you'll see in green that it's put all the points on the ground. So I can go ahead and hide this one. You'll see that, okay, we have these points, which is great, right? Now, let me try and number these points and just see like which point is first, second, third, and so on. If I try to do that, if I do point list, it may have to hide this to see this better, but see I got a bunch of zeros here, ones here, twos here, threes, and so on. I don't want that. I want to have 0, 1, 2, 3, 4, 5, and so on. So one of the things we may notice is that we have a bunch of duplicate points happening, because if I look at this corner, for example, right here where my mouse is, there's clearly 2 or more points that have fallen down and are sitting on the same spot. So the first thing I need to do is remove those duplicate points. Now there's a couple of ways to do that, but there's a kangaroo component right here from Kangaroo. There's also another great one from TT Toolbox, remove duplicate points. So you can download either one of those two and get those components. And if I put that geometry in here now, the projected points, okay, first of all, if I notice this wire, I see that there's multiple lists going in here. I don't want multiple lists because I don't want it to remove points from each list. I want all of this to be treated as one list. So if I flatten this tree, you'll see that 104 points come in, but those 104 points are coming in as 26 different lists. But over here you see that it's just 104 points in one list. And if I remove all the duplicates, you'll see that I'm left with only 16 points. So from 104, we've simplified it down to 16. And now if I use the point list component, and I gotta hide these, but what you'll see is I have a 0 here, right? 0, 1, 2, 3, 4, and so on. But they're really, you know, I mean, they're just scattered all over the place. It'll just be a little more organized if I could start in one location and then, you know, have the numbers going around in a much more orderly fashion. And the way I'm going to do that is by sorting these points out. Now, generally, if you type in sort, you'll see something called sort points. But what this does is it sorts the points in the Cartesian coordinates in general. But where, you know, so if I had a bunch of points along in one direction in the X or the Y or something, it'd be easy. But here I have points kind of going around in a circle. So it's better to sort them around something else. So again, if I try again, sort, I have one component called sort along curve, which is from TT Toolbox. Pretty sure it's from TT Toolbox. Anyway. So sort along curves. Well, anyway, just look for this, see if you have it. If you don't, you may have to download a plugin for it. But I'm going to put in the points here, the 16 points. Now ask for a curve to sort them around. And for the curve, I'm just going to draw a simple circle, since these points are kind of going in a circular motion. Okay, now I need to actually be able to see the circle. The circle is automatically created, but it's really, really tiny. Okay, so I'm going to go ahead and just start putting in a number that may or may not work. So here you see I'm just going to create a slider and just find a curve dimension that I think is comfortable to work with. So let's say right about there. Okay, and this circle is now going to be the curve that is going to sort these points around. And let's see if it works. Let's take that point list component, go up here, put the points in, and see what happened to them. So now I have 0, 1, 2. If the size is not big enough, you can't see this on your screen. I'm just going to make this a lot bigger. So just hold on. There we go. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it looks like it sorted them just right. And this really helps me out, because now what I can do is start cutting all these curves using these points. Now, what does that mean? How will I actually end up cutting these curves? What am I cutting them with? Now, I could draw a plane to cut them with, but the problem with a plane is that a plane will cut the curve in all directions, right? It considers a plane as infinite. What I want to do is, if I go in my top view, what I want is some type of surface that will cut all of the slabs in this direction, and then cut all the slabs along the 1, and then cut all the slabs along 2, and then 3, and then so on. Okay, because say I'm cutting along this corner, I'm also going to cut other slabs in this location and some other slabs down the middle or wherever that may fall, right? So how do I create these? This would be a really useful way, and one thing to do that I could try is just drawing these kind of lines, right? So let's start drawing lines that I just drew here, but using Grasshopper instead. So one of the best ways that I like to draw lines is using the SDL component, which is the line using a start, direction, and the length. Okay, so the start, I can use the 0 right in the middle because I'm going from the origin and moving out. And one way to do that is you could just right click on start and say set one point and just type in 0, and it should create a point right in the middle. If it doesn't do that, just make sure that up here, instead of type as point, which generally it might be that, just make sure you change it to coordinate, that we can actually enter the coordinates, which is 0 in this case. Okay, the direction is a line that goes from the center out to each of these points. Okay, so the direction is going to be a vector, a 2-point vector. Okay, and again, the start of the vector is going to be the same point, right? I'm starting here at 0 and going out towards each of these points, point 0, point 1, point 2, and all, but I'm always starting at the origin. Now, I just did the same thing here, right? I right-clicked and I would go to set one point. So instead of repeating that, what I can do is just right-click here on start, and this really nifty thing is extract parameter. I love this, especially when you have a situation like this. If you hit extract parameter, it takes whatever you had set in here and pulls it out. Okay, so here you have the point, which is the origin, and I could always just label this as origin so I know what it is. Put this back in here. Now, the point B, so to speak, the second point is that here, the direction. I want to go from 0 to here, so I'm going to use these points, bring them in, okay, and use that as my vector. Now for the length, I could enter, I'm just going to try 500 and see if that's big enough. It turns out to be just big enough. Okay, and there we go. I'm kind of pulling these lines out. Now, however, if you look, you'll see that these lines are just in plan, right? These lines don't actually exist in 3 dimensions. So how am I expected to cut all these curves just using these lines? Well, one thing I can do is turn these lines into a big surface, right? So what I could do is extrude these curves in the Z direction, and I could actually just extrude it as tall as the tower, and we know that number, right? We know exactly how tall the tower is from our last lesson. You'll see here that I have this number 2000. This is actually the tower height measured in inches, and I could of course just go ahead and bring this value down here. Now whenever I do something like this, bringing information from a long ways away, I usually rename what's coming in here and just hide it, so I kind of understand what type of value is going in there. Now if I look at this, you'll see that I have a bunch of surfaces, right, that are sorted along in a circle that are cutting through each of the slabs. So if I put my slabs back on, kind of see what I'm talking about. There, these surfaces are going ahead and cutting through the slab, right? And I can find out exactly where they're cutting and get those points by using the intersect component. Okay, so if I come in here, I double click and type intersect, you see that there's a couple of options here. However, you may not be able to find exactly what you're looking for if you're just using in the search. The best way is to come up here to the intersect tab. Okay, and you'll see that we're looking for a physical intersection between a curve, which is a slab boundary, and in our case, a surface or a BREF. Okay, so there is this thing called surface and curve. I can click that and bring that out. There's a whole bunch of different options here, BREF plane, mesh plane, and so on. I'm going to use surface curve for now. So put in the surface and put in the curve that you want to intersect. Now, what is the curve? The curve is still the boundaries, right, which is all the way back here. So I could, again, just copy and paste this over. Sorry, just replace that one. And surface and curve, so put that in. And you'll see that we do get some result. However, it's not exactly what we're looking for. 0 is intersecting with the one at the bottom. Number 1 is intersecting with the next one. 2 with the next one. 3, 4, 5, 6, 7. It's kind of going around in a spiral. And then, you know, it's really not doing what we want it to do. I want each slab to be cut with each of these planes. And so what we need to do is actually graft one of these. Okay, so I'm going to graft the curves in this case. What this does is say, okay, I'm going to take each curve and make it an independent list. And then each item in that list is going to go through and cut each slab. Now you see I have a lot of points over here. So just to make this look a little clearer, I'm going to go ahead and hide these extrusions that I have just made over here. Okay. And now you'll see these are all the locations where you will have a corner, any corner over here, but you can follow that corner all the way down the building. And you can pick any corner you want, and you'll see that you can find exactly where that corner is relative to the other slabs. Okay, now let's try making a polyline connecting those dots. So if I come here, you'll see I have a bunch of outputs, right? Curves, points, UV points, normals, parameters, and so on. I just want to make a polyline. Now let's see what happens if I put in these points into the vertices to create a polyline. And you see that nothing happened, right? If I hover over points, let's look at a panel and see what's happening over here. You'll see that each point is its own list, right? Each point is in an independent list. So what the polyline component is trying to do is make a polyline from each list. So this list, it only finds one point and then realizes, oh, I can't make a polyline out of one point. It goes to the next list, sees one point again, and so on. This is really not the best way to make a polyline. I want all these points in a list so that the polyline component can make a line out of them. One way to do that is using the trim tree component. And what it does is it trims it one layer down, the branches. So instead of being 0, 0, 0, 0, it's going to take it one level down. Each time it takes a level down, it reduces the structure of this tree. And we'll see what that looks like. So if I do that, apply that component and look at the next result, you'll see that I have something that has a list of 16, from 0 to 15, that is, 16 items. And I have different lists like that. Well, this should be something that works, right? Now, when this information goes into the polyline component, it's going to see a bunch of points and try to connect them together. Let's see what happens. Okay, if I hide the points and I isolate what's happening here, you'll see that the polyline component is actually operating per floor, right? I don't want it operating per floor. I want it operating in the other direction. What I want to do is, instead of the points going this way along a floor, I want them going vertically. I want to flip the direction of the points. So instead of the points being in this direction, I want them to go in the other direction. And the best way to do that is to use the flip matrix component. Okay, so without going into too much detail of what these components do, let's go ahead and use the flip matrix component, and it'll kind of speak for itself. When I put these, and so now instead of this tree data going into vertices, I go ahead and put this one in and see what happened. Instead of the data being organized by slab, it's now being organized by the plane, the intersection plane, which is really interesting. This is really close to what we're trying to get, right? The effect we're trying to achieve. However, if I go back here, you notice that the slab is actually three-dimensional, right? It's not just this outer curve. There's also an inner curve, so to speak, where it actually, you know, we can use to actually fill this out. Let's see if we can do that now. Now, of course, with any design in Rhino or Grasshopper, there's 100 ways to do the exact same thing. So the way that I think that we should go about this is, if I come here, I notice that I've drawn this circle already. So I'm thinking maybe it's a good idea that each one of these, you know, vertical fins actually like stops at this circle. So how would we actually go about doing that? Well, let's see. If I have these curves, right? It looks a little messy right now, so maybe I'll turn off these slabs. Okay. So if I have these lines, I have this polyline that I've created, I need to kind of pull that polyline back, maybe somewhat inside the slab, right? And what I can do is use this circle as a way to do that. So if I had the circle on each floor, I would not only be able to find a point that's kind of, on the corner, right? But also a point on the inside. So let's do that. Let's try to put that circle on each floor that we have in our building. Okay, so just for now, I'm going to hide these other polylines because they're getting quite busy here. Okay, let's go ahead, bring that circle up. So the circle I had made right here, I'm going to use the move component, right? And we know exactly how high to move it because we had done this before with the slabs. So if I come back up here to the slabs, you'll see that this component moved the slabs up vertically, right? And it was using these vectors. So I can just use the vector component and grab these vectors here and call them vectors to move circle up or something like that, just so I know what that vector is, not just some empty component in space. And if I apply that, you'll see that I pull the circle up to each one of these floor slabs, right? Now the next step is what we can do is exactly the same thing, where last time we had done the surface and curve intersection, okay? Except now instead of doing it with the boundary slab curves, we're going to do it with the circles that we moved over here. So I'm going to copy and paste this component. The surface is the same. We're just going to just change the curve, right? Now remember, we had grafted these curves. I'm going to do the same thing. Copy the graft command over. Put the circles in. So if I show you this component, it's basically the circles. And what graft is doing is putting each circle in its own list. And then go ahead and use that as the curve. And you see the result is exactly the same, except we're now intersecting the circle instead of intersecting the boundary. And if I follow the exact same steps as below, where I have these vertices for the polyline, I can copy and paste those three components and again just replace the input to this tree, and now I have a vertical polyline. So I have one polyline here, I have another polyline there. I'm sure there's a way that I can just connect them together, right? Now, if I was working in Rhino, what I would probably do is just loft between the two. Let's see if we can do that here. So if I use the loft component, and don't forget to save these components, this file as you go. Now, if I want to loft these, I want to loft each one of these components with each one of these vertical lines with each one of these exterior lines, right? Okay, let's look at their structure first and see what's going on. So what we see here is that each curve is in its own list, which is really useful because what all I need to do is use the merge component, okay? And what merge will do is I can take this stream, put it in here, take the next stream, put it there, and you'll see that I've actually put each one of those together with the other into an independent list, so that when I put that into loft, what the loft component is going to do is look at each pair and loft them together. Okay, so let's just have a look at that, what that looks like. Go back to here, and yeah, that's not too bad, is it? Those are probably what the fins should look like. Now again, I don't like looking at it in this red view. Even if you change it to high quality, even if you take the bump preview off, or yeah, like that, it's still not looking the way I want it. So generally what I usually do is again do something like this, where I change the shader, and I also change the way I want to look at the B-rep edges. Make sure I copy that component over, look at the edges of this component and shade them black. And if I bring in my slabs, yeah, that's pretty good. So that's one way. Of course, I'm sure whoever's watching this tutorial and is thinking of another way to do it, please make a video, show us how you would have interpreted this building. Now there's a lot of things we can do with this. We can still play with this building. So I can go back here and reintroduce those angles, 15, 30, 45, 60, 75, right? And you'll see that it adds a lot more different angles to this building. I can change the rotation by changing the seed. So maybe I'll change the way that they are being rotated, right? I can still change the number of floors that I have in this building. So I can change this to even up to 50 floors. It'll be quite tight. There's still a lot of red I see in here, so you can always go around, find out where those components are that are still visible that you don't want to see. In my case, these slab boundaries right now, and turn them off like that. Now the last thing we're going to do in the next video is do the handrails, where we're going to add some handrails to this building. So stay tuned for that.